For students on Zoom, can you hear me? Okay, great, thank you. Okay, so let's get started. We have exam on Friday night from 7 to 9 for non-DRC student, and you have extra time for DRC student. And we would not have class on Friday, so you just focus on preparing for the exam. And we will not have class next week. So I ever heard that students get crazy like Hell Week, I don't know. So you guys can just focus on the other class that you are taking. So just like there's no stress for my class, at least for the next week. And I already post all the equations you can print out before the exam, but I will, same thing, I will provide at the end of the exam so you can check during when you take the exam also. What else? Any question about the exam 3? I don't know yet. Maybe same as exam 2, maybe same as exam 1. So I can do either like 4 problems, 4 big calculation problems, or like I just make 1 calculation problem as like combination of small problems and then 3 calculation problems. So I will see. I'll post announcement once I finish making the exam. 8 to 10, I guess. Yeah. I think it's from the 4 node rectangular element, right? So CST is in the previous exam, is in exam 2. So after CST, start from the 4 node rectangular element. Any other question? Oh, and also something I need your help. The cost evaluation. I think I checked yesterday, or I don't know. Is the response rate is very low. It's like only a very small amount of students did submit the cost evaluation. So well, department keep pushing me, so I have to push you guys. They really require some like response rate for each instructor. And also I think this is very important to me, not just because the department pushed me for the response rate. It's important for me because you guys are the only audience for my whole semester. So I depend on you guys to give me some feedback so I know how I can improve in the future semesters. And I don't want like always repeat the same thing over and over again and do the same thing that is like not helping you guys. So I really appreciate if you guys can provide me some suggestion and feedback, like which part you like, which part you don't like. And I know that which part I can keep doing it, which part I can change for the future, in the future semester. So also considering it's like you are helping your friends who will take my class in the future. I will try to make it like a better experience for my future students. So that is the cost evaluation. Please submit it. And let's start with this exam review. So I think after exam 2, the first topic was the 4 node rectangular element, and this one, it only applies, everything in this section only applies when it's a rectangular element with 4 edge parallel coordinates. If it's not, don't use the equations here directly. Of course, we have interpolation, we have the K matrix, we have the nodal degree. We use the K matrix to find out the nodal degree freedom, and also if we know the nodal degree freedom, we can calculate stress, strain, and everything. So for the interpolation part, shape function. We can use this one for interpolation of u and interpolation of v, displacement in x direction, displacement in y direction. I normally don't put this one in the equation sheet, and previously students are complaining like why this is not provided. I feel like you have been starting FEA for a whole semester. You should know this. So it's like if it's CSV, then it's N1 U1 plus N2 U2 plus N3 U3. If it's the full node rectangle element, then you have one more. It's N4 times U4, right? So this part, you should know that even I don't provide in the equations. And for the strain calculation, again, this is based on the definition of the strain, partial U over partial X, partial V, partial Y. So this one, don't get confused with the isoparametric mapping, because that one, we mapping everything into ST coordinate. So there is a chamber differentiation, but for this one, because everything the shape function is already defined in the XY coordinates, and the definition is about the XY. So we can do it directly, right? So that don't get confused. Like when you learn more, you're confused with different topics and don't know which one to use. I think there's a question. What time is it? Exam is from 7 to 9. Question on 2. So now an important thing about this B matrix is that B matrix for the strain in the X direction, we know that this is a function of Y, right? So there's a variable Y here, basically mean that the strain in the X direction can represent linear change in the Y direction because it's variable Y, right? And strain in the Y direction, it can represent the linear change in the X direction because there's a variable X here. And shear strain can represent the linear change in both X and Y direction. So I think this is very important because in the real application, we know like if you have a bunch of the element type, you can choose, you know, what type is better suitable. It's better for your application. Normally software provide like more than 200 element types, so you know which one to choose. And also, you know, the capability of each element. And I think in one of our homework problems, you also need this one. So it's like if we model we do the full node rectangle element, can it give you accurate result or not accurate result? So that's why I emphasize here it's very important to understand what is the capability of the element type through this B matrix. Remember in the CST element, everything is about coordinates. There's no variable X and Y there. So it means that, well, it cannot represent the stress strain linear change in X and Y direction. But this one, it has X and Y. So please understand this part. And let's talk about this one at the same time. So for this one, for this homework problem, I think it confused a lot of students. The first confusion part is like, if you need, use G, rho, and E. And students like, okay, what equation can you use to put all these parameters in? And so this is a exercise problem from textbook. Maybe some students feel it's like a little tricky, but I personally don't feel it's like too bad, because if you understand everything and you use the method we talk about in the class, it should be fine. Because what the question asks about the strain. And if you know that, okay, in the class, we talk about strain equation. I think there's some delay. I don't know why. The strain equation, then you use this equation directly, right? Because nodal degree of freedom, they are given B matrix depend on coordinates. We can find B matrix. So if you understand, if you know this method, if you understand what the question asks, you can calculate the strain directly. So this is also the common mistake during the exam. It's like students see all the information and see, okay, let's check all the equations. Which equation I can put all the parameters in this problem in one equation and trying to get something. You will not get anything because it's like it just wastes your time and leads you to nowhere. So always start from what the question asks about. If it's strain, we know the B matrix because coordinates are given. If the nodal degree freedom are given, so we can calculate directly. The second part is explain if the calculated strain is exact or not. And somehow I copy and paste the standard solution from the textbook for the explanation part. And when I read it this morning, I feel like it confused me or not. It's the explanation. I don't know if you read the solution or not. The explanation, the standard solution. I would feel like it's super confusing. So let's make it clear. No matter what element type or like whenever it asks, it's exact or not. We just compare how does it change for the strain YY? How does it change in the actual situation, and how does it change? What the capability of element of our FEA element, right? So for this problem, let's forget about the FEA. If it has body force, how does this strain change in the y direction? Just use your mechanics materials, the knowledge from the mechanics materials. How does strain change? Yes, it's linear change, right? So you can just imagine, say, if we consider this one is a cross section here, maybe I should have something. Well, let's use this way, and the strain at the very bottom. Let's use stress because stress strain they're just like a coefficient difference for this situation, right? So let's see the stress. Let's consider the paper at the very bottom. The stress is caused by the weight of the paper above that specific paper, right? So the weight here is the largest. And when I gradually move upward, the weight of paper above gradually linearly reduce. And when it reached the very bottom, top surface, there's no paper on top of it. So the stress becomes 0. So we can kind of imagine, okay, in this situation, the stress in the vertical direction of the, let's say, body force is caused by the weight of the paper above that specific paper we are checking. And from the bottom to the top, the weight linearly decrease. So the stress is in this situation is F over, or let's say weight over cross-section area, right? So if the weight gradually decrease, linear decrease, area doesn't change, so the stress also linear decrease. And the stress strain in this 1D situation is this one for this stress strain is only Young's modulus difference, right? Coefficient difference. So if the stress is linear change, the strain is linear change. So that is the actual stress change, how the actual strain change in this problem. And now let's see, we are calculating the epsilon YY. Equal to this one times nodal degree freedom. There's no linear Y term in this element type, right? It can represent, however, linear change in the X direction, but it cannot represent linear change in the Y direction because this is no Y here. There's no Y here for the epsilon YY. That's why our element type, using the 4-node rectangular element, it cannot give you accurate results. Is this clear or not? So I guess some of you already watched my tutorial video. Let me ask you a further question. If it's Q8, can it represent, if I use Q8 to model this problem, can represent the accurate result for epsilon y or not? Yes or no? So how many of you already watched my tutorial video? Abacus. Okay. So if it's Q8, can represent accurate result or not for this one? Yes? No? Raise your hand if you think it's yes. Okay, great. Thank you. So yes, because in the Q8, it has, so let's say X, Y. Let's say Abacus use this this A term. Right. So Q8 basically means it's a rectangular element with 8 nodes. So it can have the quadratic term. So let's say for this 8 node term, and well, this these 8 terms in our polynomial for representing the displacement. And since strain or stress is derivative, first derivative of the displacement, so we know that there is a linear change y term, right? So if we use Q8, yes, it can represent accurate result. But if you use Q4, 4-node rectangular element, no. And of course, let's say if I give you 2 options, use CST or Q4, or let's say CST, LST, Q4, Q8. Which one will you use? When you're modeling it in Abacus? Watch my tutorial video, you'll figure out. So this is the this type of question. So in the end, we are comparing the how it actually changed and what is capability of element type. So remember I asked about in the exam 2. So there was one problem, a beam problem, and I think it has a distributed force, and I asked the student to explain why. And some students explain very well. It's like comparing the polynomial of the displacement based on your understanding of mechanics material and the polynomial of our FEA when we do the interpolation, and then we get a conclusion like if it's accurate or not. I think that is a very good explanation, and but some students just gave the explanation because of distributed force. Well, we didn't give you penalty, but that means it's correct. So if it happens again, you may get some penalty in exam 3. So make sure that, well, when I ask you, well, if it's exact or not, you just say because it's exact because, oh, it's approximation because that's distributed force. I mean, there's a missing link in between. Why does distributed force give you approximation, right? So I need some deep understanding of this part. So make sure that in the exam 3, if I ask like this type of question in the 2D situation, you know how to answer, not just say distributed force. Well, actually, distributed force in our 2D situation may give you a different answer because I talk about this problem, right? This is distributed force, but our FEA give you exact result. Even using the CST element, and this is a Q4 element. And I think I explained why during the class. So the question answer, can you explain what a good explanation would be for exam problem you just mentioned? So what I expect to see is that it don't just answer in a way that, oh, it's distributed force, so it's approximation like that. You need to really compare. So let's say for this problem, I really want you to explain, okay, because in the actual situation, the strain is linear change, and because our FEA cannot represent this linear change, so it's approximation. This is what I expect to see in your explanation. It's not just, oh, this is distributed force or this is concentrated force, so it's exact, or so it's approximation. I don't think that's a good explanation because I see some missing link. And also, let's continue on this one. For this one, it is distributed force, but it gives you exact result. So don't just get a conclusion that is if you consider force exact, if it's a distributed force, it's approximation. No, it really depends on different element type, different structure, different boundary condition. Right? We're dealing with beam problem, it's different thing. Now it's the 2D plane stress problem. So this is the first part. And well, for this topic, the rest part is easy. So interpolation, calculate strain. And this one also interpolation, calculate strain. So this example problem and homework problem, they are direct application of our equations I showed here. And this one I will talk about. So the next topic is K matrix. And as I said, for the full rectilinear element, we use this one to do the integration A by A matrix. For square element, we use this one and also explain during class. It does not depend on dimension, so it can be a big square or small square. It doesn't depend on the edge size. And I feel this is a fun question in the homework. It confuses students a lot. I think the main problem is that the KQ equal to F, students get confused, like, how do you write the F on the right-hand side, right? So let's just check this structure. The force, external applied force, should include the equivalent nodal force caused by the BX plus reaction force at the full boundary condition, right? And since this one is free to move in the X direction, so the, let's say if there's a R for X, this is only 0 reaction force. And for the all the other reaction force, there should be some value there because it's when it constrains the degree of freedom, there is a reaction force to constrain it, right? So equivalent body force plus reaction force. Let's say R1X, R1Y, and R4Y. And the question asked about the reaction force at node 3 in the X direction. So it should be R3X. This is something we need to calculate. And we can see here, R3X and is equal to this one times nodal degree of freedom. And there's a equivalent body force and R3X. And you can get an equation, right? And all the nodal degree of freedom, I think there's only U3X or U4. The only non-zero degree of freedom is U4. All the other 0. So you can get this equation and calculate R3X. Well, actually, now you look at this problem, and if you can understand everything, it really doesn't matter. I can ask you, what is the reaction force and node Y in the Y direction, right? It's the same thing. You just use this one times this one equal to this one. So, and also, of course, I can change the body force. I can change the boundary condition. So I can change it in any way I want. But how to solve the problem, if you really understand, it's the same problem, right? So any students still get confused about this part of this problem? Now the equivalent nodal force, I think this part is relatively easy because this is very similar to the CST element. We just like equal divide to different node if it's distributed force on the edge or its body force. And we solve this problem using the well, I think in the CST we solve this problem using the 2 CST element, and in this section, in this chapter, we solve this problem using 1 corner rectangle element. And still we use the KQ to F. K is given, K is provided. I will provide the equations during the exam. And once you calculate the nodal degree freedom, you can calculate strain. So this one I explained in very detail during the class. You can check your lecture notes. Now let's check the isoparametric mapping. So in this chapter, well, this is probably the most complicated chapter in this textbook. But if you understand, again, I feel like it's still what the problem is saying. So the basic idea is that, okay, we map in everything into the reference element. Reference element keep the same, it doesn't change. And this is the shape function of the reference element. And coordinate mapping, displacement interpolation. That's why we call it isoparametric mapping. And again, these are the equation. I expect it's something that you understand. It's not, I don't need to provide. So the coordinate mapping for any point in the field coordinate, you should be capable of calculating what the corresponding point in the ST coordinates. And the same thing in your homework, you need to find the corresponding point. So this part is just solving this equation. And for displacement, using this equation, calculate displacement, right? And also the homework problem, calculate displacement. So that's why they are the same problem. And Jacobian matrix, again, because now everything is in the reference coordinate cell, everything is about S and T, but the definition of strain and stress, they are defined with respect to X and Y. So that we need to use the chamber differentiation to like converge from X, Y, and ST coordinates. That's why we have the Jacobian matrix and the Jacobian. And Jacobian matrix is basically a relation between the partial n, partial x, partial y, and partial n shape function, partial s, partial t. So for this is the example problem I did in class, calculate Jacobian matrix and the Jacobian. And also we talk about the shortcut if it's a shape like this, right? If it's rectangle element with 4 edge parallel coordinates, there should be a shortcut to calculate. You do not need to go with the standard procedure, like have the x at the function st, y at function st, and partial derivative, and have the Jacobian matrix. We can just, based on understanding the Jacobian matrix is scaling from the physical element to the reference element, that we can write on the Jacobian matrix the 4 component directly. We talk about this shortcut in the class. So it might be, I don't know, it might be a small question. I'm not sure. I will know later. So for this, I think this one is a homework problem, and calculate Jacobian matrix. So same as our example problem in class. It's just like I changed the geometry, but no matter how I change the coordinates or how I rotate the element, the calculation method is the same. Now this one, this part are the same, and is the mapping valid or not? So we need to understand that for a mapping is valid or not. For making a mapping is valid, we need to make sure that for any point within that element, the Jacobian is greater than 0. If there's a single point that making the Jacobian equal to 0 or smaller than 0, the mapping is invalid. And also we need to consider the range of the S and T to check if it's greater than 0 or smaller than 0, right? So always using the S from -1 to 1 and T from -1 to 1, because in our reference element, S is always from -1 to 1, T is always from -1 to 1, right? So once you have the Jacobian, you have the expression, you need to make sure that, okay, for S and T in this range, if I can make sure that it always greater than 0, then the mapping is valid. If there's a point or many points, well, if there's like even a single point make this Jacobian equal to 0 or less than 0, the whole mapping is invalid. So this is based purely mathematically. And there's another way, I think I mentioned in the class, is that we check the angle, interior angle. So the interior angle, if is mathematically, if it's like between 0 to 180, it's fine. You will get Jacobian greater than 0. But if there's an angle that is greater than 180, then greater or equal to 180, the corresponding Jacobian at that point should be 0. So that's why here, when you just look at it, you see that, okay, this point, this angle is equal to 180, right? So this point should be invalid. And actually, if you put the S and T at this point, so S and T, since this is the point 2, node 2 in the reference coordinate, is 1, -1. You put 1, -1 plug into the expression, you should get a value equal to 0 or smaller than 0. So these are the, well, because let's be very realistic, is we cannot just check all the combination and ST from -1 to 1 to see if there's a single point to make it not greater than 0, right? So I think the easiest way that you just look at the geometry. If there is an angle that is like not within that range, then you put the corresponding node ST into the expression. You may get some get your conclusion. So this is about the Jacobian matrix and valid mapping. For the strain, well, for this part, I think I spent a whole class explain this one single example problem. So you should check your lecture notes for this one. And homework problem is the same. Actually, it's easier because this one asks you character strain. So for character stress, you go one more step, right? And well, I just rotate the structure a little bit or change the node order. So I consider the same problem. Convergence study. Actually, you probably don't need this term because we normally in our calculation we ignore this high order error term. So this is expression. This is the equation that we use in our calculation. And again, in your homework, a lot of students still get confused. Like I think I emphasized enough during the class. Element size means the edge length, right? So if you're clear about this part, as I saw a lot of students like using this one as edge. So this is like H1, H2. No, this is not H1, H2. This is for the first match, this number of elements is not the length of the edge. This is also the number of elements, right? So don't get confused on that. So once you know that, okay, the H1, H2, H3 first mesh, second mesh, well, we normally start from the like big element size and gradually refine it, make it smaller and smaller. So H1, H2, H3, and this P, since we define this way, P is smaller than 1. And once we have the P, we have this U can be either displacement result or stress result from given. We can calculate convergence rate, and we can calculate what is the exact solution. So this is a convergence study. Just make sure that you know what is the H for different problem. And for this one, well, I actually simplify a little bit. I use a square element. But let's say if I use a CST element, if I use the triangle element, let's say I use the equilateral triangle element, where the result is the same or different. Why? Yeah, the edge length is different, but the key thing we use in our calculation is a ratio of edge length, right? So actually it doesn't matter, because yes, so I think in the class I use, okay, since we are modeling the whole structure using the different element type, the whole area is 8, this one doesn't change. And this by divided by number of elements, let's say the first one is 100 elements, and I use square root square element, right? So this is the edge length. And let's say this is a H1 for square element. But if I use a triangle element, let's say how to calculate area. Let's remove this part. Area equal to, let's say, this is L times, right? This is the area of one element. And of course, I know for different geometry, there's a coefficient in front, but in the end, if we are comparing the ratio of edge length, this coefficient doesn't matter, right? So actually I can use any shape of as long as 2D. Like I can model the whole problem completely using the triangle element. I can use the rectangle element. It doesn't matter because in the end we want ratio. So if I change this problem using like triangle element, you should get the same answer. Right. So what I mean that, okay, area is some coefficient times L squared, and coefficient in the ratio calculation, it cancels out, it doesn't matter. And the same thing here. So let's say for this problem, we assume that since it's 3D, volume is constant, right? And we use, let's say the first situation, 1600 elements. So this is the volume of a single element. And for the ratio, I can just use this one. Oh, H2 over H1, I think. H2 over H1. Right. And students ask me, are you assuming using the cube? Again, it doesn't matter. So of course, when I say that V equal to edge length cube, this is volume of cube. And for tetrahedral, I think there is a coefficient in front. It might be this one. You can check it later, but it really doesn't matter, right? Because in the end, we want ratio of the edge length. So we can, from this comparison, we can see that no matter what so for 2D, we have the area is there might be a coefficient in front, but that coefficient doesn't matter. And for 3D, it's all about volume, edge length. And for different geometry, different element type, there might be a coefficient in front. Again, it doesn't matter. In the end, we just need a P, the ratio of the edge size. Any question here? I think we're done. So write down your name and UFID. I will give you guys attendance. And this is the last class of this semester. I want to say that I really thank you guys for your support for the whole semester. I really enjoyed this semester. It's, as I said in last class, it's like the most interactive class I have ever experienced since COVID. Well, as I was hired by our team after COVID, so I really want to say that I appreciate your support for the whole semester, and I really enjoyed this semester. Thank you guys. Do you find V in the homework problem to be able to solve the ratio? So for the problem on Zoom, do you have to find a V? No, V is, I assume that is the volume of the original structure. After you calculate the ratio, V is gone. You're welcome. Thank you. Thank you.
Appreciate it.
Thank you.
Thank you.
Thank you. Yes, yes. V is constant. Thank you. Thank you. Yeah, so for 3D, you assume V is constant. For 2D, you assume A is constant, area is constant. Thank you. Thank you. Thank you. Thank you. Yes, yes, yes. You're welcome. No, we don't need to worry about 1D. There's no 1D for this.